Hello, my darlings. Okay, today I want to talk to you about the intermediate value theorem. So first off, I want to remind us, when is a function continuous? Remember that in order for a function to be continuous at a point, it must be the case that the limit as x heads to c of f of x equals f of c. This is the definition of continuity at a point, often referred to as the three-part definition, right? I call it the 3 I's. We have to show that the function exists, we have to show that the limit exists, and we have to show that the limit is the same as the function value. All right? So that the limit from the left equals the limit from the right equals the function value. Now, the intermediate value theorem. The reason we had to review continuity is because in order for this theorem to apply, we have to know that the function is continuous on a closed interval. If the function is continuous on a closed interval, it must take on every value between f of a and f of b. In other words, if n is between f of a and f of b, then n equals f of c for some c in the closed interval from a to b. Note, f of c is n, and c is trapped between a and b, and n is trapped between f of a and f of b. Oh my goodness, that just got complicated. It was so much easier when it said, and I quote, if f of x is continuous on the closed interval, then it has to take on every value between f of a and f of b. That's the key. So here's a function f of x, okay? This is a function f of x. This is a, this is b. Then I can come across, this would be f of b, and this would be f of a. Now, no matter what value I pick in between here, I can call it n, I can call it f of c. No matter what value, any height in between f of a and f of b, any one I pick, has to have a corresponding point on the graph that is going to have an x value, I'm going to call c, that has to be between a and b. That's what the intermediate value theorem says, okay? For every continuous function, we are guaranteed to pass through the height of n at least once when f of a is less than or equal to n is less than or equal to f of b. Or it could be a decreasing function and go this way. Okay, it can go that way also. Now, the intermediate value theorem for continuous functions, that's the reason why the graph of a function continuous on an interval can't have any breaks. It's connected. The graph has to be connected. A single unbroken curve. It will not have jumps. It will not have separate branches. It has to take on every function value in between the start and the stop. That's what it means. So let's look at this example. Here's the function f of x is x cubed plus x squared minus 2x. First thing I want you to do is I want to find f of negative 3, and then we're going to find f of negative 1. So f of negative 3 would be negative 3 to the third plus negative 3 squared minus 2 times negative 3. So that's going to give us, let's see, negative 3 cubed is negative 27, negative 3 squared is 9, and negative 2 times 3 is 6. So that's going to be negative 27 plus 15. There's negative 12. And then we're going to find f of negative 1. So that's negative 1 cubed plus negative 1 squared minus 2 times negative 1. So that's negative 1 plus 1 and plus 2. So that's going to give us 2. Now, is there a root between negative 3 and negative 1, and why? Now remember, a root means that's the x value when f of x equals 0. So is there a time where the function value has to be 0? Notice at -3, we had a function value of -12. So if you think on the graph, here's -3, and here's -12. So we're way down here. At -1, we have a height of 2. Can we get from point A to point B without passing through a height of 0? Of course we have to pass through that height of 0. So our answer is going to be yes. Since f of x is continuous, now notice this y is longer than the answer, is continuous, the intermediate value theorem, IVT for short, applies. Since f of -3 is less than 0, is less than f of -1, there is a value of x such that -3 is less than x is less than -1, and f of x equals 0. See, the write-up, as always, is more difficult than actually finding the answer. Okay, that write-up for the AP can sometimes be tricky. Now I just want to practice whether or not the intermediate value theorem applies. So in each of the following problems here, we're going to decide whether the intermediate value theorem can or cannot be used to justify the stated conclusions. And then you have to explain why it can or can't. So here we go. The following table gives some function values for the continuous function g of x. Given that, they want to conclude that there exists some r in the interval from 0 to 2, so in between 0 and 2, where f of r equals 5. Now think about this, between 0 and 2, so we're looking in here. At 0, we're up here at 7. At 2, we're down here at 3. This is 3, okay, here. Is there a time where we will have to have a height of 5? Well, 5 is in between them, isn't it? Yes. Now, first thing you have to check is that it's continuous. So the first thing, why? G of x is continuous, so the intermediate value theorem applies. And g of 0, which is 7, is bigger than 5, which is bigger than g of 2, which was only 3. Okay? So there must be an r, that's just like saying an x value, such that r is between 0 and 2, and g of r equals 5. Let's try another one. Let k be this function defined by k of x equals x plus 2 when x is less than or equal to 1, and x plus 4 when x is greater than 1. There must exist some x between 0 and 2 for which k of x equals 4. Now I want you to pause and tell me what think about what your answer is. Press play when you're ready. How many of you said yes? Right? Because if you try to find k of 0, you're going to be using the top piece of function, which is 2. And then you find k of 2, which would be using the top piece of function. 2 plus 4 is 6. 4 is in between 2 and 6, right? But you guys forgot something. Is k of x continuous? Well, the top is linear, so it's continuous. The bottom is also linear and continuous. But is it continuous at 1? Let's just real quick plug 1 into the top. So when x is 1, okay, the top piece, are these two pieces going to be equal? Are they going to meet? 1 plus 2 and 1 plus 4. Are they equal? Guess what? It's not continuous. Therefore, the rule does not apply. K of x is not continuous at x equals 1. So the intermediate value theorem does not apply. Make sure you don't jump to finding the function values. You first need to know if the function is continuous. So, okay guys, remember, intermediate value theorem, first, is it continuous? Then, if you know that the function value is between two other function values, there has to be an x value in between the start and stop where it will achieve it. All right, guys, have a great day.